Well, good morning, guys. Mr. Kruger coming at you here. 12.3, solving rational functions here on Thursday. It's today, live session for those of you that are actually out in virtual world. However, when we're done with this, you need to complete your try on your own, and we are going to ask you to complete a formative assessment within It's Learning tomorrow by a particular time, so make sure you get on there and do that, all right? So what we're going to do here is a warm-up. Well, solve each proportion. Just remember, proportion is simply two equivalent fractions. And typically you were taught to solve proportions. You can use proportional reasoning, but guessing and checking really is a foolish way. But remember, we just cross-multiply 3x equals 60. And then you solve, so x equals 20 in this case, all right? Well, number 2 is a little bit different, but when I cross multiply here, and I'm not going to draw these all the time, just remember this is 3 times x plus 2 equals 6 times 8 is what? It's 48. Then I got to distribute here. 3x plus 6 equals 48. Typically, this is a step I don't show. I go straight from there to here usually. I'm going to say 3x equals 42. So x equals 42 divided by 3 is 14. Okay. Then this last one over here looks a little bit different now. Now notice I have restrictions over here at number 3. Remember, all real numbers x, except it can never equal -5. There's a restriction here because -5 is going to be undefined. However, I'm still looking to see what makes this fraction equal to 0. Well, I'm going to cross multiply. It's x plus 5 times x plus 3 equals 3 times 0 is 0. Well, I'm not going to double distribute this because that would be kind of foolish, because then I'm going to run into a quadratic. And how do you solve a quadratic? You factor it, or the quadratic formula. I'm already factored because I'm equal to 0. That was pretty nice. So I know x equals -5, and I know x equals -3. However, this -5 here, that's an extraneous solution because it's not in the domain of the function, so I need to throw it out. So the only solution is going to be x equals -3. An extraneous solution is a solution that is like a false positive. It looks like it's a solution, but it really isn't, because it does illegal things in math, all right? So what we're going to do is we're just going to keep plucking along here, and we're going to look at these methods. We're going to do, I'm only going to do 2. There is actually 3, but the third one doesn't make any sense. So how do I do this? Well, I use proportional reasoning. I cross multiply. So what does that mean? Well, I take my x plus 5 times my x minus 5. That's going to equal my x plus 2 times my x plus 1. Well, because this isn't equal to 0 like that number 3 in the warm-up was, I need to expand this thing, and I got to get my like terms put together. Well, this is going to give me x squared. Outers and inners cancel each other. Minus 25, that's going to equal x squared. There's 1x, there's 2x, so that's plus 3x's plus 2. And now I get a quadratic equation. Well, how do we solve a quadratic equation? Well, we put our like terms together. So what I'm going to first do is I'm going to move my x squared over with my x squared. And right out of the blocks, I see -25 equals 3x plus 2. Well, hey, that was actually kind of nice now. Because, why would that be nice? Because now my x squared fell out. Now I'm not getting it set equal to 0. Now I'm going to subtract 2, and I'm going to find out 3x equals what? -27. So x better be equaling -9. Is that my solution? Well, please don't forget, in the beginning here, I know I have restrictions. And my restrictions are x can never equal 5 or -2. And because the answer I got here is not in my restriction list, x equals -5 is my solution, okay? Why don't you guys go through and give number 2 a try, and please, there's a wonderful hint on here. don't forget about what you learned about simplifying, right? If you have fractions, it's always very intelligent to simplify fractions. But notice, I can only vertically simplify because this is not a multiplication symbol, it's an equal, so I cannot cross simplify, all right? I can only vertically simplify here, so I'm going to hit pause. Why don't you give this one a shot? All right, so don't forget about that hint like I said before. It's a really intelligent thing to go through and factor both of your fractions, all right? And what I notice here is I can simplify that one fraction, but prior to simplifying, notice over here I listed my restrictions. I'm listing my restrictions as a list of possible solutions that need to be thrown out, all right? So then I cruise along here, and because I simplified that, well, now I have a whole new fraction. I actually have 2 over x minus 4 equals x plus 1 over x minus 4. And so now I'm going to cross multiply those, and then I'm going to expand them. And I'm like, oh boy, I got a quadratic. I better get it set equal to 0 and put all my like terms together. So I subtracted my 2x from here, and I added my 8 over here, and I ended up getting x squared minus 5x plus 4 equals 0. How do we solve quadratics? We factor them if we can, and it's x minus 4 over times x minus 1, which means when x equals 4 and when x equals 1, I should have a solution. But notice I cross off that x equals 4 because when I took the list of possible solutions and I cross-referenced them with my list of restrictions, I had to throw out negative, or I had to throw a positive 4 because it's a restriction in the original problem. Therefore, the only solution is x equals 1, all right? Now, as I'm coming through here, this is the clearing fractions method. Clearing fractions. All you guys hate fractions. I know you hate fractions because you weren't taught how to deal with them properly. I don't deal with fractions. I don't like this. I don't want to add this and say x plus 3 over 11 equals 8 over 11. Then I got to cross multiply. I am going to multiply the whole entire equation by my least common denominator of 11. So that when I multiply that times that, I get 11x over 11. So I really have x because my 11's reduced. Plus, when I take that, I get 3 times 11 over 11, or 33 over 11. And that 33 over 11, that's 3 equals, you guessed it, 8. So x equals 5. And notice I did not make a list of restrictions here because I did not have an x in the denominator that needed to be restricted. All right? That is the clearing fractions method. Multiply by the least common denominator. Not any denominator, the least common denominator. That's what you want. Otherwise, you're going to run into problems if we do not do this. So we're going to move on here. Let's try to clear these fractions. Well, what is my least common denominator between 6, 3, and 12? I think it's 12. I do not have any restrictions that I need to see here. So I'm going to multiply everything times 12. I'm going to do this once shortly, and then I'm going to do it the easy way. Notice when I distribute my 12 here, I'm realistically going to have 12 times 3x plus 2 over 6, plus this is going to give me 12 over 3 equal, this is going to give me 12 times 2x minus 1 over 12. The reason I'm doing that and I didn't multiply it is because I want to simplify my fractions before I do anything, all right? Now notice, this 6 will reduce with the 12 and there's only a 2 left over. I can see that this, and this is going to reduce to just distributing a 2. So this whole thing is going to turn into 2 times 3x plus 2. Plus, if I reduce 12 over 3, that whole thing reduces to a 4 because the 3 reduces with the 12, so I'm really only distributing a 4 in that one, equals, and here the whole 12 reduces because this 12 kills that whole 12, so I just have a 2x minus 1. And again, no restrictions because I have no variables in the bottom. Well, this is going to give me then 6x plus 4 equals 2x minus 1, which is 6x plus 8 equals 2x minus 1, which, if I subtract my 2x over, I have 4x plus 8 equals negative 1. So I have 4x equals negative 9. And here's usually where people say, oh, I made a mistake because I'm getting a fraction for an answer. No, x equals negative 9 over 4. And I'm just straight up going to circle that answer because I didn't have any restrictions that I need to cross-reference for my answer. And that is the clearing fractions method, all right? So what we're going to do here is I'm going to work one more with you. And the first thing I'm going to do is I'm going to factor the, because see, I see this can factor. And this is going to be an x times x minus 4. So I'm going to see that out. And then I'm going to see my least common denominator in this case is going to be x times x minus 4. Because notice, everybody, if I had to add those, everybody needs an x times an x minus 4. So that gives me the green light, no pun intended, to multiply by my least common denominator. Notice I'm not multiplying by x squared minus 4x because I want to picture when I'm multiplying this, when it's over the top of this, I can see the x's are going to cancel, the x minus 4 is going to cancel. I'm just going to be left with a 6 plus. Here, when I multiply to the next one, I can see that's 4 times x minus 4. I can see my x's are going to reduce, and I'm going to be left with 4 times x minus 4. And when I distribute it to this last one, I can see it's 2 times x minus 4. And I can see these x minus 4 is going to cancel. I'm just going to be left with a 2x on top, okay? So then I say, well, this is 6 plus 4x minus 16 equals 2x, right? And then I can see here, well, this is 4x minus 10 equals 2x. So what I'm going to do is I'm going to push my 10 over here and my 2x over here because I like to keep my x's positive, right? So that's going to be 2x equals 10, which means x better be equaling 5. And here's where everybody stops and circles the answer. Hopefully you're screaming at me over through screen, Kroger, you didn't list your restrictions. You definitely want to see restrictions. Not rest, but restrictions. I don't know. I'm having a hard time spelling here. So, restrictions are x cannot be 0 and 4. 0, 4, 0, 4. Those are the only things. If I run into either one of these as a solution, I'd have to throw them out. This is not in my list, therefore x equals 5 is the solution to this equation. All right, so what we're going to do here is we're going to move to the next one. I'm going to hit pause. I encourage you to try this one on your own, and I will be back. All right, so I'm back. Now remember, in order to find your least common denominator, we need to factor everything about this thing and try to reduce it. Well, this is going to be x times x minus 2. After I factor that denominator, that is kind of dead to me. And what that is going to make me do is that's going to make me, look, number one, see my least common denominator is x times x minus 2, as well as seeing my restrictions, x can never equal 0 or 2. Then I'm going to multiply this whole business by my x times x minus 2. Okay? And when I do that, when I see this, I can see I have 10 times x minus 2 over x times x minus 2. And I can see these are gotten rid of by that, so I'm only left with a 10 in the top of that one. And when I distribute this, I have 1 times x minus 2. I can see this gets rid of that, so I'm really only distributing an x minus 2, 1 times x minus 2 equals this, when I distribute here, really is 3 times x minus 2 over x minus 2. I can see this gets rid of that, so I'm really only distributing a 3 there. Okay? Then what I do is I'm going to distribute, and when I distribute, now I'm going to put my like terms together, and what I'm doing here is I'm moving my x over there with the 3x, and I'm combining those to get 2x equals 8, and that means x equals 4, and I'm not getting hastily right away. I still am taking this, and I'm comparing and saying, hey, you are not in my list of restrictions, therefore I am keeping you and circling you for my answer. Last page. When is it good to use proportional reasoning? That is cross-multiplying, personal preference. It is only good to use when you have one fraction equal to one fraction. Okay? As a matter of fact, you cannot use proportional reasoning if there is more than one fraction on either side. Okay? So, when does proportional reasoning cause the problem to become more difficult? Well, that is when there is more than one fraction on either side. Okay? And I put in there in parentheses, when this happens, we want to multiply by the least common denominator because that will clear the fractions. Now, last one. Use extraneous solutions to explain why identifying the restrictions is helpful when solving equations. Well, that is because sometimes when you solve a problem, like we solved in let's see, it would be number 2 and number 3 in the beginning, in the warm-up. Okay, sometimes you get a false solution. What are you talking about? The solution is a restriction, meaning if I list my restrictions at the beginning and I cross-reference that list, and if my solution is in my list of restrictions, I throw it out. The very last one is you need to know when to throw out a potential solution. That's kind of restating what I did before. You need to know when your solution is a restriction, and if that happens, you throw it out. You guys have a great rest of your day.